In this video, I'm going to talk about transforming graphs by shifting. Let's take a look at the graph y equals to absolute value of x on decimals. It is an upward V-shaped graph with an angle of 45 degree down and 45 degree up, with the vertex at the point 0, 0. Let's try to write another equation. Y equals to absolute of x minus 5. This new graph has a shape that resembles the original one, but the position is shifted down by 5 units, so that the new vertex is now at 0, -5. Furthermore, if you look at other values of x, for example, x equals -4, originally, -4 absolute value will give you the y value being 4. So you will have -4, 4 as one of the points on this graph. Now, when you plug in -4 into the new equation, you get absolute value of -4, which is 4, minus 5. So the y value will be -1. Compare -4, 4 and -4, -1. You can see that this point is also shifting down by 5 units. What if we replace this minus 5 by, let's say, plus 2? What will happen to the graph? You may guess that this graph will then be shifted up by 2 units. And you're perfectly right. Let's take a look. This graph is now having a new vertex at 0, 2. And if you look at this particular x value, 2, you can see that it shifts up from 2, 2 to 2, 4. Now, instead of shifting up and down, what if I want to shift this graph to the right by 2 units? What can we do? We know that adding and subtracting numbers after we finish the absolute value would not work, because this would only shift graphs up and down. If we want to shift the graph to the right, then what we need to change is the x direction. So maybe we should try y equals to absolute value of x plus 2. Wait a second. We were expecting this to give us shifting to the right. But now, what has happened? The new vertex is -2, 0, meaning that this graph is a shifting of the original to the left by 2 units. This is really counterintuitive, isn't it? Maybe the program is wrong? This is always possible, so we should verify using our mathematical knowledge. When x is -2, plugging it into the equation, we will have -2 plus 2, which is 0. And after you take the absolute value, the y output is indeed 0. So the program is right. What has happened? It turns out that when we do x plus 2 in the equation, what we have truly done is to shift the x-axis to the right by 2 steps. 0 gets shifted to 2, 2 gets shifted to 4, 3 gets shifted to 5, etc. Imagine the original blue curve stays untouched, and we are only shifting the x-axis to the right by 2 units. Then the new position of the vertex will be -2, isn't it? Therefore, when we try to graph this equation with the axis aligned, the new graph will be shifted to the left by 2 units instead of to the right. If we truly want to shift this graph to the right by 2 units, then what we should do is to change the function into absolute value of x minus 2. This is because the x-axis is now shifted to the left by 2 steps, and hence, if the graph stays untouched, then it will be equivalent to shifting the graph to the right by 2 units. Let's summarize what we have seen. If we have equation y equals to fx for some function f acting on x, now changed into y equals to fx plus c, where c is a real number that can be positive or negative. Then what we have done is a vertical shift of the graph. Where we are doing an upward shift if c is positive and downward shift if c is less than 0. And because of this, we will say that this action follows our intuition. This is because we are only adding c after we finish the function f of x. So each time we calculate the output value of f of x, and then we make the adjustment of adding c to it. So of course, the effect is reflected in the vertical direction. On the other hand, if we have y equals to f of x changed into y equals to f of the input x plus c, then we are performing a horizontal shift on the graph. Where the graph is shifted left if c is positive and right if c is negative. Because of this, we will say that the action is counterintuitive. This is because the input x is now changed into x plus c. So the x-axis is shifted. If the x-axis is shifted to the right because of positive c, then it looks like your graph is shifted to the left. If your x-axis is shifted to the left because of the negative c, then it looks like your graph is shifted to the right. Before we end this video, let's take a look at one more example. Consider the equation y equals to the square root of 5x. If you want to shift this equation by 1 unit to the right, then what does the new equation become? Is it y equal to square root of 5x minus 1? Y equals to square root of 5x plus 1? Y equals to square root of 5x minus 1? Or y equals to square root of 5x plus 1? Which one do you think is correct? It turns out that none of them is correct. The first two are actually referring to vertical shift. The first one is shifting down by 1 unit, while the second one is shifting up by 1 unit. How about the last two equations? Well, we call that any horizontal action will be counterintuitive. Counterintuitive means that shifting to the right would require minus 1, and therefore this will be ruled out. As for the third one, many people might think that this is the correct answer. However, let's take a look at this more closely by letting y equal to fx to be our function square root of 5x. To shift this graph rightward by 1 unit, we need to do y equals to f of x minus 1. This is provided by the previous slide. F of x minus 1 means that we are substituting x minus 1 into the function, and hence what we get is square root of 5 times of the number x minus 1, which will become square root of 5 times of x minus 5 if you want to expand this, but we usually don't and accept this as the correct final answer. And you can see that this answer is different from this answer. And so, please make sure that you do not make the same mistakes in any of the problems that you're solving. Thank you very much for watching this video. If you like it, please subscribe to our channel and we will learn more fun math together. Thank you.